Welcome to Radio VTV. I'm Alina.
I'm DJ DynaMatt.
Okay, DJ DynaMatt, let's kick things off with Duckmandu. The four elements of Radio VTV are science, art, music, and charity.
We start with the art of Christina Tiger Ramos.
And then, let's get ready for live musical performances from 25 different musicians. Hit them with the theme song, DynaMatt. Boom!
You are watching Radio VTV. You are watching Radio VTV. So we have Tiger Ramos. How are you?
Hi, how are you? Thanks for having me.
Oh, thank you so much for being on the show. So I found out about you because you're part of the Year of the Snake show at 111 Minute.
Yeah, correct. Yeah, right now it's a great show with a lot of talented people there.
So the theme was the Year of the Snake, but there's looks like there's about like 32 different artists.
Mhm.
And
I did one large piece. They had a size limit, and then I did completely skip the rule and did a much larger one. But I've done that. I've done that quite several times. I don't know, like if I like paint small size. It feels like I'm not getting the point across if I do it too small.
Well, it probably has to be the size that it has to be.
Yeah.
Make sure everybody get out to 111 Minna. The show will be going until January. And you can see the art in real life as well as so many other artists. So after that, you have a sounds like a super cool show coming up in Paris.
Yeah, we're doing there's a tattoo convention in Paris, last one of its kind. Um, it's been running for 20 years, and it's become quite like expensive to make because of pandemic, inflation, and problems. So regrettably, the owner decided to not continue with it. I'm sure it will translate into other events in the future, but as of now, they decided to do the last Mondial du Tatouage show for now. And we're kind of sad, but also very excited because everybody's gonna come and it's probably gonna be all out. And yeah, we're very excited to go.
That's so cool. So now the art that the people are seeing on the show right now, that's that would be like your fine art, but your primary art would be tattoo art. Is that correct?
Yeah, that's how I make a living for
Mhm.
sure. Yeah, I mean, sometimes people have their different perceptions of it. I guess for me, I like to combine both, uh, and some of it is more work, and some of it is more creative. You like, and same with painting. Although lately for me, painting has been a little bit more creative, and I have a little bit more freedom to just express and kind of like do my own thing.
Sure. Well, I mean, when you're doing a tattoo, you're doing it for a client, so they probably have something very specific. But when you work on a piece of paper, it's probably whatever's in your mind.
Yeah, and I think like I have to be very very technical when I work as a tattooer, whereas a painter sometimes I can skip a little bit of the technicalities and let it flow a little better.
That's
But
so
at the end
cool.
of the day, I always end up being technical because it's kind of like an addiction. So.
Well, I love your line work and I love your shading, and it appears that your hand is so steady that you're able to do basically photorealistic work. But you also seem to know the work well enough that you're free to ignore the rules when you choose to.
Yeah, it's yeah. Sometimes I mean, during tattooing, there is certain things that I have to follow just because, and these rules come out of like what I know is gonna work from experience. So you got to stick to those for the sake of longevity and having that tattoo last properly over the years. But um, there's so many aspects to tattooing and tattoo art, and they're so different than painting on a canvas. Like a canvas, like yeah, you have to worry about the longevity of it, but not as much because the canvas is not as organic and as dynamic as the skin, so you don't have to worry as much in that regard.
Now, people can find your work. You have a website. You're also on Instagram and TikTok. We'll post the links to that. It's Tiger_Ramos.
Yes.
And then you're also available for hire for tattoo, primarily in the Los Angeles area, but you're also going to be coming up here to the Bay.
I'll be arriving actually right after New Year's Eve.
Okay,
So
in January.
I'll stay there for like about a week and a half, depending on how good it gets. Um, and I usually work at Seven Sun, and sometimes I pick a few days at Diamond Club as well.
Super cool. Well, okay, so for sure, if you book an appointment with Tiger Ramos and you get a tattoo, definitely send it here to Radio VTV because we want to see it. Thank you so much for being on the show tonight. We really appreciate it.
Thank you so much for having me. That's great.
husks in the valley, move steady westward to the fountains and alley. Now through winter's broken jaw, you can feed off beneath you, let it thaw. It's sweetest green you ever knew. Blades of grass can cut our melodies are fire through winter's wasted funeral pyre. The heat is going greater still. It's the ever greatest growing state.
So we started off the set with DJ Qbert trading flares with Shortcut at the QFO release party in San Francisco. After that, we had post-industrial punk band Babyland performing. They're out of Los Angeles, but they were up here in Berkeley. And the drummer laid a 50-gallon barrel on the stage. They turned off the lights and used a metal grinder to send sparks into the audience. Then we had Marissa Haskell and Hillary Hufford performing live on my radio show. We had Caravan 222 out of Los Angeles. And then we finished up the set with the Pleasure Kills.
Now we have Professor DynaMatt McGillicuddy with experimental physicist Dr. Chris O'Grady.
All right, welcome back to the Couch of Science. I'm Professor DynaMatt McGillicuddy. Once again, joined with Chris. Welcome back.
It's a joy to be back.
Happy to have you here. So, last time we got to discuss a little bit about particle accelerators, and I followed up on some of the stuff that you discussed. You were talking about how the trough that we send the particles through is referred to as an RF wave, or an RF trough. And I looked into that, and it fits in with my show. The RF is for radio frequency.
Radio frequency.
So yeah,
Correct.
so like a radio frequency, we're sending particles of light towards people full of knowledge. So this is like our own little particle accelerator.
It's exactly right. Yeah, the radio frequency, it's the same idea. The frequency of the electromagnetic waves.
So cool. So now, one of the things you talked about is that if there's a wiggle, it can give off an X-ray pulse.
Yeah, that's right. If you wiggle with a magnet, the electrons going down the particle accelerator, and they will kick off a little particle of light called a photon.
Oh wow, so it actually generates photons. Super cool. Okay, and so it's with that photon that they're X-raying.
That's correct. And so at our accelerator, what happens is that as the electron bends, it emits a photon, and then you try to have the next bend be timed so that its photon that it generates overlaps with the previous one. And so you keep adding photons to this wave, and the strength of the bend determines the frequency of the photon. And if you add up enough of them, you get a very short sine wave of electromagnetic light, and that is a very short laser pulse.
Oh wow. Okay, so it's an electromagnetic. So is it giving off everything on the electromagnetic spectrum? Is it generating microwaves and gamma waves, or is it just the...
You tune it so typically so that it generates, there's a range of frequencies, but typically they'll try to get it so it's one frequency to a good approximation.
Okay, so that's why you tune it to create an X-ray.
Yeah, it's like a single tone of music. That one frequency. And the reason that you want one frequency in many of these cases is that you're going to use these photons and bounce them off the equivalent, if you had a rock in a pond, if you had many different waves of different frequencies, it would kind of turn into a mess. But if you have a regular pattern of waves, when the waves hit the rock in the pond, you'll see a pattern that comes out that's that you can understand, called a diffraction pattern.
Almost like a bat, like with its sonar. Like it generates it from a bounce back of the solid object.
Yeah, in this case, the diffraction pattern, like the bat, the bat in this case is the accelerator generating the X-rays. The X-rays smash into some target, but it's one frequency of X-rays, and then they diffract just like water in a pond, and you get a pattern that shows up on your detector. And coincidentally, just earlier today, I was at the lab, and actually for 12 hours straight yesterday, fixing a $2 million detector that we had from Switzerland, which broke because there was too much network traffic on the subnet that we used to communicate with the X-ray detector. And we were messing up an experiment of the Photosystem 2 people because of this network traffic. But we fixed it just a few hours before your radio show.
Holy
so
cow.
now those experimenters have the X-ray camera to go see the results of the X-rays hitting the target, which is happening even as we speak.
Wow, that is so cool. So very timely.
Very timely.
That's so awesome. So now, with this X-ray pulse, is it okay to call it a pulse?
Yeah, that's what we call it.
Okay.
We get coming down the accelerator. The old accelerator does about 120 pulses per second. The new accelerator does between currently 33 kilohertz, and then it eventually hopes to go to a megahertz.
Oh, we should pull an errand. So what key is 120? Is that going to be B?
Is 120 hertz?
120 hertz.
I don't know, but I know that 110 is an A.
Yeah.
So, you know, it's probably...
A440 is the old tuning fork.
Exactly.
So you're doing a X-ray in the key of E.
X-ray in the key of E. I've never heard it referred to that way, but that's...
Probably B. Somewhere around there.
We should figure out what key it is, because yeah, that, I would like to call it that. That is, I've never heard that before.
Oh, actually, now that I think of it, because it's a multiple of 60, which is the 60 hertz cycle hum. I know the 60 hertz cycle hum is between B flat. Yeah, the 60 hertz cycle hum is between B flat and B. I just know this. And so that means the 120 is exactly the same note, because it's times 2. So, yeah.
There we go. So cool. Oh, that's awesome.
And that, so yeah, I'm going to start calling it X-rays in the key of B flat.
There we go.
And as an aside, that's the reason the old accelerator runs at 120 hertz is the 60 cycle hum idea, because they,
Oh, right, of
they
course, yeah.
tie the RF cavities that are the waves that the electrons ride on to the frequency of the wall power.
Right.
And that's why it's
Interesting.
120 hertz.
That is so cool. So when I was in Egypt, I got to see an obelisk that was maybe like, I want to say like 30 stories tall. And it had been keyed. It had been toned to B flat.
Really?
Yeah.
Huh.
So there must be something about B flat that we just don't know about. That's interesting. Okay, so it's interesting how many things end up being connected. So yeah. So next time you're there, yeah, we'll patent it. DynaMatt, Professor DynaMatt McGillicuddy is patenting it. It's now X-rays in the key of B flat.
I love it.
We'll get T-shirts for that. Oh, that's so cool. So now, what are some of the things that we have learned by X-raying on an atomic level?
So one of the big things that happens is we image things like proteins, and by we I actually mean other people. I'm more responsible for the instrumentation and data handling, and so it's done by other experimenters. But yeah, imaging proteins is a big one. So by looking at the X-ray camera, at the diffraction patterns, and every time you put a protein into the beam, it's in a different orientation. And so you get a different diffraction pattern depending on this random orientation. And each time you take a picture of the diffraction pattern, and you take all those diffraction patterns and you merge them all together. And by doing that and then doing a Fourier transform, which I can't explain very well, then you can get back to the structure of the protein. And if you know the structure of the protein, in some cases, you can perhaps make a new medicine that would either hinder or help that protein if you know the structure.
Okay.
So
Like in the
imaging
formula.
proteins for medicines or disease prevention is one of the things that happens.
That's so cool. Wow, that is so cool. So it's basically like identifying it with an X-ray on an atomic level of a protein, probably to learn the mechanics of the thing, how something's going to form or how something's going to stop from being formed.
That's correct. And you can also look at the time evolution of these the proteins or some other chemical reaction. And the way that is done is that a laser is sent some number of femtoseconds before before the X-ray hits the target, and then and a femtosecond is a millionth of a billionth of a second, and then you study how the diffraction pattern changes depending on that separation of the laser pulse and the X-ray pulse. And then you get a movie. So you say, at 1 femtosecond it looks like this, at 2 femtoseconds it looks like this, at 3 femtoseconds it looks like this. And then you build up this movie of what the reaction looks like when you inject energy into this system.
Oh, wow. So cool. So one of the things that we talked about that I definitely wanted to bring up on the show is through the use of this X-ray, we've been able, and I'm going to say we, not that I actually have even looked at this thing, but in the human sense, I often say we when I'm talking about scientists and science, like sports fans get to say we when their team does well, because for me that's the team I'm rooting for. So we as humans, or primarily you and your buddies, and me just as the cheerleader going, go team, have made a major breakthrough in understanding photosynthesis through these X-rays.
Yes, there's a group, particularly from Berkeley, and that's the group that is at the lab, I believe, right now, using this X-ray detector, who looks at photosystem 2, which is what's called a catalyst. Plants can take carbon and CO2 and uses the energy from the sun to make hydrocarbons and oxygen, which we breathe. But that is a very difficult chemical reaction to make happen from an energy point of view. So what a catalyst does is it's like a post-it note. It's like a chemical that's a little bit sticky, but not too sticky, and it can help the chemical reaction proceed with less energy. So photosystem 2, and I'm not a super expert in this, but I have some knowledge of it, worked in catalysis for a few years. The photosystem 2 is a catalyst that plants use in order to make hydrocarbons, which we eat, and oxygen, which we breathe. And so if you could understand how this catalyst works, one could imagine that you could make better artificial fuels, and we would be less dependent on the Middle East for fuel, or so it's things like that that would be good to understand with photosystem 2, and at our accelerator we can look at the time evolution of photosystem 2, and you can see that there are, I believe, manganese atoms at the heart of the photosystem 2
So cool.
catalyst.
Just naturally.
I guess the plant in its DNA assembles the catalyst as part of, from the instructions in its DNA in a way that I couldn't possibly understand. And it makes this magical thing that helps split water and joins the hydrogens to the carbons and joins the oxygens together to make the air.
So I'm going to back up for a little bit, just for our viewers. So as I understand this, and by all means, correct me if I'm wrong. Okay, so the first part we would want to understand is water electrolysis. So we have water, which is H2O, or hydrogen and oxygen, and you can boil water, and you're going to get little molecules that are still H2O. But if you hit water with a certain voltage, you can separate the bond and get hydrogen and the oxygen. Previously we had Alex discuss chemistry, where he was saying that's normally done in a two-step, where they'll get the hydrogen first and use some of the protons to get the oxygen, but that's the basic of water electrolysis, is just separating the H from the O. So there's carbon everywhere. I'm breathing out carbon, I'm generating carbon, I'm made of carbon. Plants have no problem getting carbon. There's carbon everywhere. And then water lands on the plant, H2O, and the roots pull it up. And from what we've been able to learn, the leaves will absorb electrons from the sun and then do internal water electrolysis and separate the hydrogen from the oxygen and then it attaches the hydrogen to the carbon to make a hydrocarbon, and you get more plant, more fruit, more leaf, more whatever, and that the plant has, and then the byproduct is oxygen, which it releases. Is that about correct?
I think that's correct. I think you did say it's not electrons from the sun, it's photons from the sun.
Photons. Okay, photons, not electrons.
Yeah, the photons are absorbed by the leaf, and then the photon uses that to create the electrons and the protons that are used in the chemical reactions that you described.
That's so cool. And so if we can learn more about this process, then we could start generating our own hydrogen fuel.
Yeah, your own hydrogen fuel. Yeah, your own hydrocarbon fuel that you could imagine would be carbon neutral. Because you could take CO2 out of the air and make hydrocarbons, burn it, which then puts it back into the air, but it would be a closed cycle, would be the dream. And then you would have less global warming.
Oh, that's so cool. So it's definitely something worth looking farther into. So yeah, I really appreciate you coming back and talking more about this. This has been really fascinating. If you have questions for Chris, definitely post them in the comments. I've really appreciated everyone's input so far on this. So I'll have to remember that. It's not electrons, it's photons that get absorbed by the leaves.
Photons from the sun, and then the energy from those is used to liberate the electrons and protons that are used in the chemical reaction. You got it.
Super cool. Super, super cool. Well, thank you so much, Chris. I really appreciate you telling us about this.
Really enjoy being here as always, Matt. Thank you so much.
Thought that I learned colors wrong, but as I grew older, that's when the doctor confirmed that I was colorblind. So today, we're opening up these glasses that my dad bought for me for my birthday. They're made by a company called Chroma. Such a difference.
They worked!
Up next, let's visit the California Science Center to see a spaceship, and you wrote the music.
Yep, that's right. I wrote music for the next feature, and I can see using this song on multiple features coming up. This is DynaMatt.
Thank you to Enchroma.
And thank you to Log by Blamo.
Thank you to MHA. And to our new sponsor, Brandu.
The Thirst Mutilator.
Oh!
Thank you to 111 Minute Gallery for introducing me to Tiger Ramos.
Thank you to the California Science Center.
We are now up to 39 subscribers, and I want to say a thank you to each and every one of you. I really appreciate you subscribing to the show and watching, and we're up to 60 hours of view time, which also, that's because of you, so thank you very much for doing that.
Thank you, subscribers.
Yeah, if you feel like I earned it, go ahead and give the show a like.
Follow us on Instagram and Facebook. Tune in next week to Radio VTV.
We'll wrap things up with a song by Religious Girls.
Oh wow, Religious Girls.